All right, so today we are actually jumping ahead to chapter 5 for one lesson. In your book, this is section 5.2. It's all about dividing when you have like bases. We're throwing this in with chapter 4, though. You'll see why. It's a lot of the exponent rules that we've been talking about. And today is day 4. So here are the steps. So go ahead and write these down. There should be a space in your notes for these. So when you are dividing with like bases, the first thing you want to do is decide where your answer is going to go. So look if you have more, let's say x's in the top or in the bottom of your fraction, because we're dividing. If there's more in the top, your answer will have that variable in the top. If there's more in the bottom, the variable will be on the bottom of your answer, okay? I always say decide where the leftovers go. That's where you write the base. And then to figure out what the exponent is, you just subtract the exponents. And then there's a nice little note at the bottom. When the exponents are the same, it simplifies to give you the number 1. So like x to the 5th over x to the 5th. You could subtract the exponents, that's x to the 0, and anything to the 0 power is 1. Or just remember that anything over itself in fraction form gives you the number 1. Any questions as you're writing that down? So I'm going to write a little bit of an explanation off to the side. If you find this helpful, you can sneak it into your notes. If not, just go ahead and sit back and watch. So x to the 9th we know is x times 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 x. I think that's 9. 1, 2, 3. Okay? And on the bottom, 1, 2, 3, 4. Everyone agree with me so far? Remember that any number over itself gives you 1. So that's a times 1. That's a times 1. That's a times 1. That's a times 1. How many do we have left over? 5. And are they in the top or the bottom of our fraction? The top. Great. That's exactly what we're doing today. But we're not going to write it out every time. We're just going to subtract the exponents and decide where the leftovers go. So do you have more x's in the top or more x's in the bottom to start off with? The top. So our leftovers are going to go in the top. Then just take the larger exponent minus the smaller exponent. What's 9 minus 4? 5. So our answer here will be x to the 5th. You might feel tempted to put it over a 1, remember, but that's just a whole number, so don't even worry about it. Questions on that? All right, here's part B. Give you a second to write this one down. Again, I'll show you just on this one example what this actually means. So we have x and x, 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 x. Where are the leftovers and how many? The bottom? 2. And there's 2. Okay? You can get that very quickly without writing all of this stuff out. Just subtract these. 4 minus 2 is 2. You had more in the bottom. Your answer needs to stay in the bottom. And then you just need a placeholder in the top. We use the 1 as the placeholder. Any questions? All right, here's C. Now, the coefficients in the front, that's just a regular old fraction, like 16 over 18. Just simplify it like you always do. What's 16 over 18? 8 over 9. What happens to the x's? They're gone, and then you just have a y in the top. You could. The question was, can you put the y to the side of the fraction? You can, but honestly, I wouldn't mess around with that. If it was in the top, I'd just leave it in the top so you don't accidentally put it in the wrong spot. All right, here's part D. All right. How many? Where are they? 5 on the bottom. So we have 1 over b to the 5th. Perfect. Yes. P to the 4th over p to the 4th. Any number over itself is just the number 1. If you want a middle step, the way we've been doing it, 4 minus 4 is 0, and anything to the 0 power is the number 1. Questions on that? Don't put 1p, don't put p to the 1st. It's the actual number 1. Questions? All right, here's F. So handle the regular old fraction up front, 12 and negative 72. Does anyone know what can go into both of those? 12. 12 does go into 72. It goes in 6 times. So you can cross out the 12, make it a 1. Cross out the 72, make it a 6. And then take care of your y's. Y to the... It is. I just left the negative here. Yeah, y to the 4th, top or bottom? Bottom. So you need that 1 up top. I usually put the negative with the top, but in the computer it's easier to just put it out in the front. Or with the bottom, any way you want to put it. Just put it in one spot, either top or bottom or out front. Questions on that one? All right, here's G. Once again, let's deal with those whole numbers out front first. Not really whole numbers, it's a fraction. Negative 7 and 28. 7 goes into both of them. 7 goes into 7 one time. 7 goes into 28 4 times. All right, a to the 2nd over a to the 1st gives us a to the 1st in the top. B to the 3rd over b to the 1st gives us b squared in the top. Where does the c go? Stays on the bottom. Boom. You don't need the negative 1 up top. It's just kind of extra writing. But as you saw in the homework, sometimes I realize you just kind of sneak it in there on accident. It's fine. It's fine if you put it. It's better if you don't. Questions? Yes, ma'am.
Wait, why wouldn't you put it on the bottom, like the A's and B's?
Because there were more A's in the top than the bottom. So our leftover A's go in the top, our leftover B's go in the top, and then the C is the only C, so it stays put. All right, here's H. All right, so I have a negative over a negative. So what's going to happen up front? Positive, good. What's 12 over 20?
4.
4 goes into both of them. So it's 3/5, good. R squared over R is R in the top. S over S squared is S on the bottom. Good. Questions? All right, here's I. Now, you'll notice that yesterday's rules start to sneak in here, okay? So in my last class, someone was automatically like, it's 1. Why is this not 1? Yes, ma'am.
Because we gotta multiply 4 by the imaginary exponent with 3 and then
Yeah, so that will end up giving us this, right? We multiply both of these 1 exponents by the 4 on the outside. Now, do you see how the 3's have the same base? You can follow these tricks even when the base is a regular number. The base doesn't have to be a variable to do the subtraction trick, okay? So what is the exponent 4 minus the exponent of 1? 3. So you'll end up with 3 to the third, which is what? 27. For the x's, we add x to the fourth over x to the fourth. Now, if you got a little carried away and we're like, well, I know 3 to the fourth is 81 over 3. What's 81 divided by 3? 27. You get the same answer. You're kind of doing more math than you need to. But I understand how you might just say, oh, 81 over 3, but keep it going. Any questions? All right, here's Jay. Oh, sorry. You sure? Yeah. Okay. We'll do a few more like that. All right, what's the next step going to look like? Good, you got to multiply all the exponents inside the parentheses by the exponents on the outside of the parentheses. So you will end up with this. The 2 is to the third power. The x up top to the second to the third is x to the sixth. In our denominator, you multiply the exponent of 1 by the 2. You get 2 to the second, x to the sixth again. What happens next? Who does? The x's. So the x's are going to simplify. They're gone. 2 to the second on the bottom, 2 to the third on the top. It's just going to be 2. Yeah, it's 2 to the first. Again, if you multiplied it out, you'd have 8 over 4. Well, 8 over 4 is 2. So, makes sense. All right, here is K. All right, ideas? The x's are gone. Good. 2 stays the same. You subtract the 8 and the 5, you get y to the third. And where do I write that? On the bottom. Keep that 1 as a placeholder up top. All right, this one's kind of tricky. What do you think we need to take care of first? The exponent on the top. Good. So take each of those to the 7th power. So this is, since it was in parentheses, a negative number to the 7th power. If you have a negative number to the 7th power, it stays negative, okay? Now what? So this whole term up top is negative. The b's are going to go away. And then I have a to the 6th. Now, does that become positive?
No.
It does not, because there are no it is even. But what would I need in order for that to become positive?
Another nickel.
Yeah, well, you'd need these guys, right? Okay. In order for us to keep the parentheses with the exponent, you would have had to have a negative a on the bottom too. Okay? That's why that works out like that. I actually kind of have to stop and pause on these as well, just to kind of think it through. If it helps you, write out 7 negative a's up here. 1, 2, 3, 4, 5, 6, 7. Okay? We all agree with that? And then write out 1a in the bottom. Okay? And then start getting rid of them in pairs. Those are gone. Those are gone. Those are gone. We still have a negative. Okay? And that negative is not to the 6th power. This is a very tricky concept. Does that help to write it out like that? Because that comes up in a few of them on the homework. So pay attention to when you need the parentheses and when you don't, and when it will turn it into a positive and when it won't. That rhymes. What an elegant way to finish the lesson. Any questions? Okay, let's summarize what we did. What did we do today? Added fractions. Dividing. Exponents. Why don't we say it dividing expressions with exponents? Because when you say dividing exponents, it sounds like we actually divided the exponents. But we subtracted the exponents, so I don't want you to get confused. All right. Any questions?